Welcome students in the previous year question session 2. In the previous year session 1 we did some question. So again we are came for the class 12 physics chapter number 7 previous year question. So let's begin with the first question which we have. In an AC circuit V and I are given below. Then find the power dissipated in the circuit where V is given. V is equals to 50 sine 50t volt and I is equals to 50 sine 50t plus pi by 3 times pi by 3 milliampere, where pi by 3 is a phase difference. Students, the answer is given like options 0.625 watt, 1.25 watt, 2.50 watt and 5.0 watt. The solution of this question. Power we know that is a Vrms, Irms cos phi. So that Vrms is equals to we know that is a V naught by root 2 I naught by root 2 cos phi, or this we can write up as a V naught I naught by 2 into cos phi. We just put this value of each factor like V naught 50 I naught 50 by 2 into cos phi. The phase difference, as you can see here, this is a given pi by 3. So I'll just put this value over there and get the result like P is equals to 0.625 watt. According to this, the correct option for this question is 1. Moving ahead with the next question. In a circuit, LCR are connected in series with an alternating voltage source of frequency. When the current in the circuit leads the voltage by 45 degree, the value of a C 1 by 2 pi f, 2 pi fl plus r, 1 by 2 pi f, 2 pi fl plus l, 1 by 2 pi f l plus r and 1 by 2 pi f r plus 1 by l. So let us see the solution of this question. We know that tan phi is equals to xl minus xc by r is equals to minus 1 as the current lead voltage by 45 degree. So 1 by omega c minus 1 omega l is equals to r. When we calculated the value of a c over there, this will becomes 1 by omega l plus r. So we know that omega L plus R. So omega is equals to 2 pi f. If we just put the value of omega is equals to 2 pi f, the correct option will become the option number 1. Moving with the next question, a capacitor of 50 microfarad is connected to a power source. V is equals to 220 sine 50t. V in volt, T in second. The value of RMS current in ampere is 0.55 ampere, root 2, 0.55 by root 2 and root 2 by 0.55 ampere. So the solution part is IRMS is equals to VRMS by XC. IRMS is equals to VRMS by 1 by omega C, or we can write up as a VRMS omega C. We just put all these value like VRMS is given over there 220. And the value of a 1 by omega c is a root 2 into, so what we can write up over there like a 50, this is the value of a frequency is a given, okay, omega is a given, and the value of a c, as you can see over there, 50 microfarad. So I'll just put 50 10 to the power minus 6 over there. Okay, again for a more elaboration, VRMS is equals to V naught by root 2. So for that scenario, V naught is a given here. This is the value of V naught by root 2. Omega is a given. This will be omega. So this is a given 50. I'll just put 50 and the C over there. So C is a given like this. Okay. So if I just put all these value, so the answer will becomes 0.55 by root 2 times A ampere. Understood? So according to this, we can say the correct option for this question is option 3. Next question we have, a series LCR circuit is connected across a source of alternating EMF of changing frequency and resonate at frequency F0, keeping capacitance constant. If the inductance L is increased by root 3 times and resistance is increased R by 1.4 times, then resonant frequency now is 3 to the power 1 by 4 F naught, root 3 F naught, root 3 minus 1 to the power 1 by 4 F naught, and the fourth one is 1 by 3 to the power 1/4 F naught. This is the correct answer for this question. Now move with the solution, like how this will become. So we know that frequency is inversely proportional to the root of L. So change in frequency, that new frequency will be also proportional to the 1 by under root of L prime. So F naught by F is equals to under root L by L prime, which is becomes under root L by root 3 times of L, which after solution we can say that 1 by 3 to the power 1 by 4. So F naught prime, that means the change in the frequency, we can calculate F naught times 1 by 3 to the power 1 by 4. Frequency is independent of R. Now, the fifth question is, the number of turns in the primary and secondary coil of a transformer is 50 and 200. Okay, so as you can see over there, the primary number of turns is a 50 and the secondary is 200, like a number of a 10. If number of turns is a less than the second number of turns, so the primary is a less than secondary, this is a step up transformer. Step up transformer. If the current in the primary coil is a 4 ampere, then the current in the secondary coil is 1 ampere, 2 ampere, 4 ampere and 5 ampere. So the solution part, if I am just going, so IS by IP is equals to NP by NS. From here, if I just put the value for IS and IP, so IS we have to calculate, and IP primary current we have to given at a 4 ampere, and the primary secondary coil number of turns also given, so easily we can calculate the value of IS, which comes 1 ampere. According to this, the correct option for this question is option 1. Hope you understand and find out also which type of a transformer is this. So this is a step up transformer. Next question we have, the natural frequency of an LC circuit is a 1,25,000 cycle per second. Then the capacitor C is a medium of a dielectric constant K. In this case, the frequency decreased by 25 kilohertz. The value of a K is 3, 2.1, 1.56, 1.7. So let us see the solution of this question. We know that as a situation for a natural frequency, we know that omega square is equals to 1 by LC. So frequency comes 1 by 2 pi under root LC. If I'll just put like the ratio of F by F prime, this will becomes 1 by 2 pi under root LC. When there will be a dielectric constant inserted, so the new frequency 1 by 2 pi under root KLC. After little bit of solution, this will become under root KLC by LC. So, after putting all these value like a F, we have a given 1,25,000. Second, change in frequency is a given, like this will be a 10,000. So, if I just calculate the value of a K, so this will be 1.56. That means the correct option for this question is the third. Next question we have, the electric current in AC circuit is given by the relation I is equals to 3 sin omega t plus 4 cos omega t. The RMS value of a current in the circuit is in ampere. We have an options 5 by root 2, 5 root 2, 3 root 2 and a 1 by root 2. The solution part which we have, we know that IRMS square is equals to 1 by t, 0 to t, 3 sin omega t plus 4 cos omega t whole square dt. So the value of IRMS is equals to 5 by root 2. According to that, we can calculate the value of IRMS current also. So after solution, the value will becomes, this is a wrong place, this is a value 5 by root 2 comes. Next question we have a resistor 20 ohm, inductive reactance 15 ohm connected in the series in an AC voltage source. V is equals to given 200 root 2 sin omega t. We have to calculate the maximum current in the circuit is. So students, these are the option 10 root 2, 10 ampere, 20 ampere and 10 root 2 ampere. Solution if I am going through. So the question is a given, actually the source is a given. V is equals to V naught sin omega t. This will be the actual equation where we can calculate the value of V naught, which is a given 200 root 2. The value of a sin omega t, omega is terms in the given omega. Resistor 20 ohm. Inductive reactance is a given 15 ohm. Okay, so we know that IRMS is equals to I naught by root 2 or I naught by root 2, or we can say IRMS is equals to VRMS divided by R square plus XL square minus XC square. So XL is equals to XC for the maximum current situation that we know. And IRMS is equals to VRMS by R. So IRMS is 10 root 2 ampere is the K. That means the correct answer for this question is 10 root 2 ampere. How this will become? So students, VRMS is a given. VRMS we can easily calculate it also. VRMS is equals to V naught by root 2. So this will becomes 200 root 2 by root 2, that means 200, and R value is already given 20. So 200 and resistance is given 20. Okay, sorry, yeah, if there will be a VRMS complete is given 200 root 2. So after solution, this will becomes 10 root 2 ampere. I hope you understand the phenomena. Next question we have a 0.01 ampere Henry inductor and root 2 pi ohm resistance are connected in series with 220 volt 50 Hz AC source. The phase difference between the current and the EMF is pi by 4 radian, pi by 2 radian, pi by 6 radian and pi by 3 radian. The solution with this question, tan phi is equals to L omega by R. Tan phi is equals to 0.01 into 2 pi into 50 divided by root 3 times pi. If I'll just put all these value together, we get the value of phi, which is a pi by 6 radian. According to this, the correct answer for this question is the third one. Next, we have a series LCR circuit is connected to a source of alternating EMF 50 volt. And if the potential difference across the inductor and capacitor are 90 volt and 60 volt respectively, the potential difference across the resistor is 400 volt, 40 volt, 80 volt or 1600 volt. So let us see the solution of this question. We know that the value of V is equals to under root VR square plus VL minus VC whole square. The value of a V is given 50 and VR we have to calculate it, and now VL is given 90 and VC is given 60. So just simple calculation there will be needed. 50 is equals to VR square plus 30 square, that means 50 square plus VR square plus 30 square. After a little bit calculation, we get the value of a VR, which is 40 volt. According to that, we can say the correct option for this question is 2. Next question we have the inductance L, which is in millihenry, of the coil which is to be connected in series with a capacitor of 0.3 picofarad to get an oscillatory frequency of 1 megahertz. So option is given 8.44, 84.4, 844 and 8440. Now move with the solution part. We know that n is equals to frequency. N is equals to 1 by 2 pi under root LC, and square is equals to 1 by 4 pi square LC. So from here we can calculate the value of L, which is equals to 1 by 4 pi square n square C, where n is the frequency. N is the what? Frequency. And C is the capacitance. So now put all these values which is we have already given and get the result, which comes 84.4 milliampere. According to this, the correct option for this question is the 2. Next question we have, if EMF E is equals to 4 cos 1000 T is applied to an LR circuit of inductance 3 millihenry and resistance 4 ohm, the amplitude of a current in the circuit is 4 by root 7 ampere, 1 ampere, 4 by 7 ampere, 0.8 ampere. The solution of this question we have, the amplitude of the current in the circuit is I is equals to E naught by Z, or I is equals to E naught by under root XL square plus R square. For that scenario, we can calculate the value of I also, which is equals to 4 by under root omega L square plus R square. According to that, the fourth option is the correct option after putting the value, as we can see over there. So this is a 0.8 ampere. I hope you understand. Next, we have a question. A choke of like a resistance. So a choke of is preferred to be a resistance for a limiting current in an AC circuit because choke is cheap, there is no wastage of a power, choke is compact in size, or choke is a good absorber of heat. So the correct answer for this question is choke coil offered no resistance to flow the current. According to that, there is no wastage of a power. That's why we are taking the choke is a preferred to a resistance for a limiting current in an AC circuit. Next question we have, in an AC circuit, an alternating voltage E is equals to 200 root 2 sine 100t volt is connected to a capacitor of capacity 1 microfarad. The RMS value of the current in the circuit is 100 milliampere, 200 milliampere, 20 milliampere and 10 milliampere. So let us see the solution of this question. IRMS we know that is a VRMS by XC, and IRMS is equals to VRMS into omega C, because VRMS and XC is equals to 1 by omega C. So when we put this term upside in a numerator, that will becomes VRMS omega C. So put all these value and get the value of IRMS, which is a 20 milliampere, and VRMS is equals to V naught by root 2. So that will becomes 200 root 2 by root 2. This will be 200 volt. So XC is equals to 1 by omega C. From that, we can calculate the different values. But the question is that we have to calculate the RMS value of a current, which we calculated earlier, that is at 20 milliampere. Next question we have, an AC ammeter is used to measure current in the circuit. When given direct current passes through the circuit, an AC ammeter reads 3 ampere. When another alternating passes through the circuit, AC ammeter reads 4 ampere. Then the reading of this ammeter, if DC and AC flows through the circuit simultaneously, is 3 ampere, 4 ampere, 7 ampere and 5 ampere. So the correct answer for this question is I resultant is equals to I1 square plus I naught square by 2. Hence I naught is equals to IRMS root 2. So IRM is 4 amperes, so I1 is equals to 3 ampere. According to that, we can say that I resultant is equals to under root 3 square plus 4 square. That will becomes 5 ampere. According to that, the correct option for this question is the fourth one. Next question we have. The power factor of an LR circuit is 1 by root 2. If the frequency of AC is doubled, what will be the power factor? 1 by root 3, 1 by root 5, 1 by root 7, 1 by root 11. Solution we have. This is the diagram. Tan phi is equals to L omega by R. Cos phi is equals to 1 by root 2, so theta will be 45 degree, and tan 45 degree is equals to L omega by R. So tan phi prime is equals to 2L omega by R. And if I just put all these values over there, so cos phi prime is equals to comes 1 by root 5. According to that, the correct option for this question is 1 by root 5. Next question we have. In the given circuit, the reading of a voltage V1 and V2 are 300 volt each. The reading in the voltmeter V3 and ammeter A are respectively. This is the circuit diagram. And options are 150 volt with the 2.2 ampere, 220 volt with the 2.2 ampere, 220 volt with the 2 ampere, and 100 volt with 2 ampere. So the correct answer for this question is second one. For the solution criteria, we know ammeter reading I is equals to V by R. At resonance, we know VL is equals to VC. If I just put all these value here, so V is equals to comes in the form of VR is equals to 220, and I is equals to 220 by 100 is equals to comes to 0.2 ampere. According to that, we can say the previous answer which we accepted or chosen, that will be the correct. The question number 18 is, in the circuit shown below, the key K is closed at time t is equals to 0. The current through the battery is first Vrm1 R2 divided by R1 square plus R2 whole square, R2 square at t is equals to 0, and V by R2 at t is equals to infinite. V by R2 is at t is equals to 0, and V R1 plus R2 divided by R1 plus R2 at t is equals to infinite. V by R2 at time t is equals to 0, and V R1 R2 divided by R1 square plus R2 square at time t is equals to infinite. The fourth option which we have, V R1 R2 divided by under root R1 square plus R2 square at time t is equals to 0, and V by R2 at t is equals to infinite. The correct option is the second one. Let us see the solution of this question. So at t is equals to 0, inductor behave like an infinite resistance. So at t is equals to 0, I is equals to V by R2, and t infinite, inductor behaves as a conducting wire. So I is equals to V equivalent divided by R equivalent. If I just put all these values together, we get this final result. Now the next question we have, in a series LCR circuit, R is given 200 ohm and voltage and frequency of the main supply is 220 volt and frequency 50 Hz respectively. On taking out of the capacitance from the circuit, the current lags behind the voltage by 30 degree. On taking out the inductor from the circuit, current leads the voltage by 30 degree. The power dissipated in the LCR circuit is 305 watt, 210 watt, 0 watt and 242 watt. Answer will be 242 watt. The solution for this question, tan 30 degree is equals to XL by R is equals to omega L by R. Tan 30 degree is equals to XC by R is equals to 1 by omega C by R. So under resonance, XC is equals to XL, power consumed V square by R. So I'll just put all these values together and get the result, that is a 242 watt. Next question we have, power dissipated in an LCR circuit connected to an AC source of EMF E is E square by R, E square R by R square plus L omega minus 1 by omega C whole square, E square under root R square plus bracket L omega minus 1 by C omega square by R. Third, we have E square R square plus L omega minus 1 by C omega whole square by R. And the fourth, we have E square R divided by under root R square plus L omega minus 1 by C omega whole square. Solution which we have, like we know the value of a power which is equals to I square R, and P is equals to E by under root R square plus XL minus XC whole square to the power whole 2 R. So P comes E square R by R square plus XL minus XC whole square. According to that, we can say the correct option is the first one. Next question we have. In an AC circuit, EMF E and the current I at any instant are given respectively by E is equals to E naught sin omega t and I is equals to I naught sin omega t minus 5. The average power in the circuit over a one cycle is E naught I naught by 2, E naught I naught by 2 sin phi, E naught I naught by 2 cos phi and E naught I naught. Solution we have average power over a complete cycle of AC PAV is equals to E naught I naught by root 2 cos phi. That means P average is equals to E naught by root 2 or I naught by root 2 cos phi, means I naught E naught by 2 cos phi. According to that, the correct option is third one. Next question we have, in an LCR circuit, the potential difference between the terminals of the inductance is 60 volt, between the terminals of the capacitor is 30 volt, and that across the resistance is 40 volt. Then supply voltage will be equals to, we have an options are 50 volt, 70 volt, 130 volt, 10 volt. So move with the solution. E is equals to under root R square plus XL minus XC whole square. So E is equals to under root 40 square plus 60 minus 30 whole square is equals to 50 volt. According to that, the correct option is option 1. Next question we have, an AC source of angular frequency omega is fed across a resistor R and a capacitor C in series. The current registered is I. If now the frequency of a source is changed to omega by 3 but maintaining the same voltage, the current in that circuit is found to be half. Calculate the ratio of inductance to the resistance at the original frequency omega. So this will be options are given, like first one root 3 by 5, root 2 by root 5, 1 by root 5 and root 4 by root 5. Solution we have, in CR circuit impedance Z is equals to, we know that under root R square plus 1 by omega C whole square. So what we are using, V is equals to IZ. After putting all this value, we get the value of x1 is equals to 1 by omega 1 C and x2 is equals to 1 by omega 2 C, and the ratio of I1 by I2 is equals to 2 also. So x1 by x2 is equals to 3, so x2 is equals to x1 by 3. x1 by r is equals to root 3 by root 5. According to that, the correct option for this question is 1. Next question we have, what is the value of inductance L for which the current is a maximum in LCR circuit with C is equals to 10 microfarad and omega is equals to 1000 radian per second. Option we have, 100 millihenry, 1 millihenry cannot be calculated unless R is unknown, and 10 millihenry. So the solution which we have, at resonance, XL is equals to XC, that we know, and omega L is equals to 1 by omega C. So L we can calculate 1 like L is equals to 1 by omega square C. If I just put this value, so get the value of L which is 100 millihenry. According to that, the correct option is 1. Next question we have, in an AC circuit the voltage applied is E is equals to E naught sin omega t. The resulting current in the circuit I is equals to I naught sine omega t minus pi by 2, where minus pi by 2 is the phase difference. The power consumption in the circuit is given by P is equals to E naught I naught by root 2, P is equals to 0 and P is equals to E naught I naught by 2 and P is equals to root 2 times E naught I naught. So the solution which we have, the given circuit current is lagging the voltage by pi by 2, so current is purely inductive and there is no power consumption in the circuit. That's why the current will be the P will be 0. Next question we have, in a series resonant LCR circuit, the voltage across R is 100 volt and R is equals to 1000 ohm, C is equals to 2 microfarad. The resonant frequency omega is 200 radian per second and at the resonance voltage L is 2.5 10 to the power minus 2 volt, 40 volt, 250 volt, 4 10 to the power minus 3 volt. So solution which we have, at resonance again XL is equals to XC. So current flowing through the circuit is I is equals to VR by R. So voltage across L is given by VL is equals to IXL is equals to IXC. So I is equals to 1 by omega C and I is equals to 0.1 divided by 200 into 2 into 10 to the power minus 6. So 1000 by 4 is equals to 250 volt. According to that, the correct option for this question is like 250 volt. Next, we have a question. A coil of inductive reactance 31 ohm has a resistance of 8 ohm is placed in the series with a condenser of a capacitive reactance 25 ohm. The combination is connected to AC source of 110 volt. The power factor in the circuit is dash. First one 0.56, second 0.64, third 0.80, 0.33. Solution which we have, cos phi is equals to r by z, cos phi is equals to r by under root r square plus xl minus xc whole square, which gives the answer 0.80, which is the option number 3. Next question we have, in a circuit LCR circuit is connected in a series with alternating voltage source of frequency f. The current leads the voltage by 45 degree. The value of C is 1 by 2 pi f, 2 pi f L plus r, 1 by f pi f, 2 pi f L plus r, 1 by 2 pi f, 2 pi f L minus r, and 1 by nf, 2 pi f L minus r. Solution which we have, tan phi is equals to, we know, omega L minus 1 by omega C times divided by R. So tan 45 is equals to 1 by R, 2 pi FL minus 1 by 2 pi FC. R is equals to 2 pi FL is minus 1 by 2 pi FC. So 1 by 2 pi FC is equals to 2 pi FL minus R. C is equals to 1 by 2 pi F, 2 pi FL minus R. According to that, the correct option is 3. Next, we have a question. A 50 Hz AC source of a 20 volt is connected across the C as shown in the figure. The voltage across R is 12 volt. Then the voltage across C is, we have an options. The option we have, this is circuit diagram, 18 volt, 16 volt, 10 volt. Not possible to determine unless value of R and C not given. Answer is 16 volt. Solution is resolution potential or resultant potential V prime is equals to under root VR square plus VC square. V prime is equals to 20 under root VL on VR and VC is given 144. VC is not given, so we have to calculate the VC and that will be 16 volt. Next, we have the phase difference between the alternating current and the EMF is a pi by 2, which is the following. Cannot be constituent of the current circuit. So C alone, RL, IC, L alone. The correct answer, is with the solution. So in LR circuit, phase difference between the current and voltage can have any value between 0 to pi by 2 but never equals to pi by 2. Hence an RLL. Next question we have, a circuit has a resistance of a 12 ohm and impedance 15 ohm. The power factor in the circuit will be 0 0.8, 0 0.4, 1.25, 0.125. The answer we have with the solution, power factor AC is equals to cos phi is equals to RZ. R by Z is equals to 12 by 15, 0 0.8. The next question we have, the primary to the secondary turns ratio of the transformer is given as 2:3. If the current through the primary coil is 3 ampere, then the current through load resistance is 1 ampere, 4.5 ampere, 2 ampere and 1.5 ampere. Solution, NP by NS is equals to IS by IP. We just put this value and the current value we find, that is a 2 ampere. Next we have in an LCR circuit, the voltage across each of the component L, C and R is 50 volt. The voltage across the LC combination will be 50 volt, 0 volt, 50 root 2, 100 volt. Solution, we have a voltage across LC combination V is equals to under root VL minus VC. So V is equals to VL minus VC is equals to 0. That means 0 volt. Next, we have alternating current cannot be measured by DC ammeter because AC cannot pass through DC ammeter. AC changes direction. Average value of a current for a complete cycle is 0. DC ammeter will get damaged. Answer is, average value of a current for a complete cycle is 0. For a full cycle, AC consists of two half cycle. One half current is a negative, another is a positive. So because of that, overall current average out to be 0, while DC ammeter reads average value, hence alternating current cannot measure DC ammeter. Next question we have, in an LCR circuit connected to an AC source operating at angular frequency omega is equals to 1 by under root LC and voltage amplitude V naught, the algebraic sum of the potential difference across the capacitor and inductor is omega is less than VC, V naught by omega L, V naught by omega L, that both become same. And the fourth one, so this you can say under into omega L. Solution, we have XL minus XC is equals to omega L is equals to omega 1 by omega C. So VL minus VC is equals to 0. So V across inductor and capacitor is 0. That means the correct answer for this question is 0. Next we have, in an LCR circuit, the capacitance is changed from C2 to C for the resonant frequency to remains unchanged. The inductance should be changed from L to 4L, 2L, L by 2 and L by 4. So the solution, we have omega is equals to 1 by under root LC, or 1 by under root L prime C prime is a constant. So LC is equals to L prime C prime, LC is equals to L prime 2C. So L prime is equals to L by 2. Hence the correct answer for this question is option 3. Next, we have a transformer changes 220 volt to 22 volt if the current in the primary and secondary coil are 10 ampere and 70 ampere respectively, then the efficiency will be 100%, 90%, 70% and 80%. Solution of this question is eta is equals to Vs Is by Vp Ip into 100%. So if I just put all these value, we get the value of eta, efficiency 70%. Next, we have in an oscillating LC circuit, the maximum charge on the capacitor when energy is stored equally between the electric and magnetic field is Q by root 3, Q by root 2 and Q. So, solution, we have energy stored in the capacitor E is equals to half Q square by C. So, half Q square by C is equals to half Q square by C. That Q is equals to Q by root 2 comes in the nature. So the correct answer is third. So this is all about for the today's session. I hope you like the session and understand the concept and the formulas. So till that, for next video, take care.